Hello, welcome to Zigmatech Learninghub. I will be your instructor for mathematics. For this class, we are going to be taking our exercises from the Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, GC, KCPE, IJMB, JUPEB, BECE, SSCE, NCEE, and NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class, okay? Let's get started. You are welcome to our mathematics class. The topic is matrices, part 1. Let us look at our specific objectives. At the end, you're expected to define matrices, or know the definition of a matrix, explain special matrices, solve problems on addition and subtraction of matrices, identify the order of a given matrix, provide solution on multiplication of matrices. Now, definition of a matrix. Matrix is just a rectangular array in which numbers or elements are arranged in rows and columns. When we talk about the rows, simply the x-axis, that is horizontal line, while the columns, the vertical axis, y-axis, horizontal line, horizontal, then vertical. So whenever you place numbers in rows, 1, 2, 4, 6, this is just a matrix. If you watch this, when we join it together, you see that it will form a rectangle. That's why we say it's what? A rectangular array in which numbers or variables or elements are arranged in rows and columns. Special matrices. Let us look at the different special matrices we have. The first one is the symmetric matrix. A matrix is said to be symmetric if the matrix is equal to its what? Transpose. What do you mean by transpose? Transpose is simply transforming a row into column, or horizontal line, the horizontal axis into vertical axis. That is, if I have a matrix, say A equals this, then the transpose A, that is A power T, equals what? 1, 2, 4, 6. Can you see that you have transformed this? This is the row, bringing it to column. The row, bringing it to column. You call it what? Symmetric matrix. Another one we have is the skew symmetric matrix. Okay, the skew symmetric matrix, if a matrix, or when the transpose of a matrix is equal to its what? Negative. Look at that sample there. Skew symmetric. That's a matrix given to us. The transpose, this is a matrix A, equals 0 minus 2, 3, 2, 0 minus 5, minus 3, 5, and 0. Now, the transpose, 0 minus 2, 3, 2, 0 minus 5, minus 3, 5, 0. Now, for a matrix to answer the name skew symmetric, when the minus or the negative of the matrix given to you is equal to its transpose. So minus A implies minus times 0 is 0, minus minus plus, minus A minus, minus A minus 2, 0, minus times minus plus, which is 5, minus times minus, this is plus, minus, minus, 0. Now look at the original matrix here. C is transpose. Now the minus of the original matrix equals who? The transpose of the matrix. You now call it what? Skew symmetric matrix. We have the one we call the square matrix. A matrix with equal number of rows and column is known as square matrix. For instance, I have 2 by 2, 3 by 3 matrices. Provided the number of rows is equating the number of columns, you know that it is what? A square matrix. The next one is the diagonal matrix. Talking about diagonal matrix, a matrix is said to be diagonal when the numbers or elements above or below the principal diagonal are equal to 0, but not simultaneous, meaning that the zeros either appear in above or the zeros appear below. You call it a diagonal matrix. Look at the instance of it. If I have this matrix 2, 0, 1, 4, 0, 0, 3, 2, 1. Principal diagonal, this way. The numbers above, or the elements above, they are all what? 0. You call it diagonal matrix. But at times, it may appear downwards, but there must be numbers here to make it diagonal matrix. But if the ones above are all 0, and the ones below are also all 0, then here becomes unity. You call it a unit matrix. Let us talk about the unit matrix. A unit matrix is just a diagonal matrix in which the elements or numbers above and below are all equal to what? 0. But the leading diagonal is what? Unity. What do I mean by that? The unity I'm talking about is when the leading diagonal, they are all 1, 1, all through. Look at it. 1, 0, 0, 0, 1, 0, 0, 0, 1. Look at the leading diagonals. They are all unity. That is 1, all through. The numbers above, all 0. The ones below, all 0, meaning a unit matrix. You don't need to struggle with this by knowing the difference between a diagonal matrix and what? The unit matrix. Once again, recall that a unit matrix is what? A diagonal matrix in which the leading diagonal or the leading principal diagonal, they are all what? Unity. That is only thing that can make a matrix to become a unit matrix. Otherwise, it can never be called a unit matrix. The line matrix, talking about line, line means horizontal. That is the x-axis. A matrix is said to be line matrix when it has only one row with either 2 columns, 3 columns, or 4 columns. But it must be what? One row. That is, if I have 4, 5, 6, this is what? Linear matrix. Column matrix is a matrix with only one column, with either 2 rows, 3, 4 rows, etc. But it must be what? Just one column. Look at the example. I have 1, 5, 6, 8. Okay? This is just what? One column, that is C1. If you watch very well, you can see row 1, row 2, row 3, row 4. But what we are considering is the column nature of the matrix. It must be what? Just 1. That is what we call what? A column matrix. Okay, the next thing on stage now is the addition and subtraction of matrices. This one is just a simple thing. Like you know addition, the normal addition you know is still the addition that you are talking about. The normal subtraction is what we are still talking about. Now let us take an example on addition. Given that A equals 2, 4, 4, 7, and B is what? 5, 4, minus 7, and 7. Find A plus B. It's just a simple addition. The matrix given to us is just this way. I have matrix A to be equal to 2, 4, then 4, 7. Then B, I have 5, 4, minus 7, and 7. Now we're looking for A plus B. A plus B equals what? 2, 4, 4, 7, plus 5, 4, minus 7, 7, to give us what? 2 plus 5, 4 plus 4, 4 plus minus 7, 7 plus 7, to give us what? This is 7, minus 3, 8, 14. So the solution is what? 7, 8, minus 3, and 14. That is the solution to that question now. The next one is what? Given that A is this is 3 by 3, and B is this. Find I, A plus B, and A minus B. We are now bringing in the subtraction aspect of it. Now let us see how we can handle it. That's A equals 7 minus 2, 3, 2, 0, minus 5, minus 3, 5, and 0 for A. Then B equals 5 minus 2, 3, 2, 3, minus 5, then minus 3, 5, and 0. A plus B equals 7 minus 2, 3, 2, 0, minus 5, minus 3, 5, and 0, plus 5 minus 2, 3, 2, 3, minus 5, minus 3, 5, and 0. Then you add 7 plus 5 is 12, minus 2 minus 2 is minus 4, 3 plus 3 is 6, 2 plus 2 is 4, 0 plus 3 is 3, minus 5 is minus 10, minus 3 minus 3 is minus 6, 5 plus 5 is 10, 0 plus 0 is 0. So the solution is what? 12 minus 4, 6, 4, 3, minus 10, minus 6, 10, and 0. Now it is time for A minus B. Now for A minus B, all you have to do, remove this addition sign. You now put subtraction sign by saying A minus B. That is bracket 7 minus 5 minus 2 minus minus 2, 3 minus 3, okay? 2 minus 2, 0 minus 3, minus 5 minus minus 5. Then minus 3 minus minus 3, 5 minus 5, 0 minus 0. It will give us what now? This is 2, 0, 0, 0, minus 3, 0, 0, 0, 0. Look at what we have now as the solution. 2, 0, 0, 0 minus 3, 0, 0, 0, 0. That's what we have. Okay, that is the result for the subtraction of matrix. There's another fancy one you can see in the form of equation. Maybe something of this nature. Find the values of P and Q. To look for value of P and Q, find P and Q. If 3 into P plus 1, 4. 4, 6, then minus bracket 2, 6, 1, 8 equals 1, 0, 4, and Q. It's still not what you're doing. This place simply means 3 times P, which is 3P plus 3, plus who? 12, that is 3 times 4. Another 12, this is 18. Then, subtraction of matrices is coming into play. Equal to this 1, 0, 4, and Q. Nothing changes. So, 3P plus 3 minus 2, 12 minus 6, 12 minus 1, 18 minus 8, all equals to who? 1, 0, 4, and Q. So that 3P plus 1, 6, 11, 10 will be equal to who? 1, 0, 4, and Q. By comparison, look at what you have. Provided you know you are looking for the value of P and Q, you must apply wisdom. With respect to their positions, 3P plus 1 is equating to who? At the right-hand side is pointing to 1, okay? You call it equation 1. YQ is pointing to who? 10. You call it equation 2. Therefore, Q equals who? 10. You have solution for Q already. For P, 3P equals 1 minus 1. So that 3P equals 0. P will now be what? 0. Therefore, P and Q equals what? 0, 10. That is the value of P and Q, 0 and 10. Let us look at another thing here, the order of a given matrix. This order of matrix is very important because of multiplication of matrix. When we started from the definition of a matrix, I made you to know that the horizontal axis or the row is called the x-axis, and the vertical, which is the column, is known as what? The y-axis. To determine the order of a given matrix, you must consider x before y, meaning row against column. But some of you, when you want to count or you want to determine the order of a given matrix, you'll be calculating or considering column against row. It is what? Wrong. So it is row against column. Now let us take some questions from past question using Examguide. But before that, let me give you one sample on the order of matrix. Let's say A equals 2, 3, 6, 1, 4, 8, 3, 6, 9. So what is the order of this matrix? The order now, this is row 1, row 2, row 3, column 1, column 2, column 3. Recall I said row against who? Column. That is row by the column. The last row here is how many rows do we have? 3, meaning 3 by 3. You can say 3 times 3. How many columns do we have? 3. It becomes what? 3 by 3 matrix. Then when you have this 1, 4, 6, 2, 8, 4. The order of this matrix is number of rows. How many rows are here? 3. How many columns are there? 2, meaning 3 by 2 matrix. Okay, taking another sample from past question using Examguide, UTME 2001. question number 13. Given the matrix K equals 2, 1, K equals 2, 1, 3, 4. K equals this. Then the matrix, comma, the matrix K square plus K plus I is the 2 by 2 identity matrix so we have to find the value of this, that is K square plus K plus identity matrix. That's I represent identity matrix. Now, first of all, you must know what is called identity matrix. If it's 2 by 2, look at it. I equals 1, 0, 0, 1. This is 2 by 2 identity matrix. If it's 3 by 3, I equals 1, 0, 0, 0, 1, 0, 0, 0, 1. All the leading diagonals, they are what? Unity. Meaning identity matrix, when we're talking about the unit matrix, what we consider, as we said, it is what? A diagonal. The numbers above and below, they are all what? 0. But the leading diagonal, they are all what? Unity. Now, this time around, it has been given to us as a problem to handle. So, you have K already. But we are told to solve K squared plus who? K plus I. What is I? 1, 0, 0, 1. Then what is K? K is 2, 3, 1, 4. Then all squared. Okay? Plus K again. What is K? 2, 1, 3, 4. Plus who? Identity matrix 1, 0, 0, 1. So what do you have now? The square here is, it must lead us to multiplication of matrix, though we've not started that, but later we'll talk about it. Okay, this is 2, 1, 3, 4 into 2, 1, 3, 4 plus 2, 1, 3, 4 plus 1, 0, 0, 1, 2 by 2 identity matrix. We'll multiply this against this. That is 2 times 2 plus 1 times 3 for the first place. Then this 2 times 1 plus 1 times 4 for this column. The next is this 3 times 2 plus 4 times 3. Again, this side, 3 times 1 plus 4 times 4. Close it. Then plus this is 3. This plus this is 0. This plus this is 3, 5. Okay. Now let us interpret this place. This is 4 plus 3, 7. All right. This is 6 plus 12. That's 18. This time this, that's 6. This is 16 plus 3, 19. Plus 3, 0, 3, 5. To give us this plus this. That's 10, 6, 21, 24. So you are done solving. Okay. 7 plus 3 is 10. 6 plus 0 is 6. 18 plus 3 is 21. 19 plus 5 is 24. So that's the solution to that question. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and give a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.